In the book, the current chapter we're working on is interfaces, and that is chapter 8 in the older versions of the textbook. Interfaces allow for code reuse, and one of the examples that's used sometimes is if you have multiple bank accounts and you want to know the bank account with the highest balance, and then you also maybe have tellers that have a drawer with cash and coin in it, and you want to know the highest coin value in the teller's drawer. In both cases, you're looking for the highest numeric value. So instead of writing methods in each class that are basically doing the same thing, which would be a little tricky too because you would be doing it at the individual object level, so that's another little wrinkle that would be hard to code around. You can write this more global interface that allows you to take all of a certain type of object and compare a value and then return, say, the highest, or you could return the lowest, or you could do an average. So the interface gives you the ability to write code once that you might find that you need to use with multiple different object types. And it gives you a way to sort of keep an aggregate value, a high, a low, an average, something where you're looking at multiple objects across the class to get a value. So I thought a better example might be the idea of the programming problem for Chapter 8, or interfaces, which is this idea that the local elementary school is going to have a fundraiser every spring, and the school does several things at the fundraiser. They auction off one really nice item, so the highest or maximum bid wins that item. Students who can attend can win a prize for their class and their teacher. So the class with the highest number of students that attend gets a prize, as does the teacher of that class. So now we're looking for the highest participation rate. And then finally, students and their siblings can play games similar to like the Chuck E. Cheese style games where you get tickets, and the one person with the highest number of tickets at the end of the night wins a prize. So we have the idea of three different object types. We have bids, we have a classroom, we have players of the games, and they're all different. And we're going to want to find the highest bid, the highest number of tickets, and the classroom with the highest number or amount of participation. So an interface gives us a way to write the code once to do that and to reuse it with the different object types. In order to do that, you do the same thing that you're used to doing. You're going to create a bids class, a classroom class, and a player class. And you're going to have instance variables and methods in those class, and then you're going to use an interface to help you finish it out. So I start off with my player class. This is going to help us figure out who's got the highest number of tickets at the end of the evening. So ignore this implements measurable for right now. Everything but that should look pretty similar to what you've been doing. You've got your two instance variables, name and total tickets. You've got your constructor. Notice I'm using the word this because the parameter names are the same as the instance variable names. So what I'm saying here is this parameter, which is the private string name is, should be set equal to the passed in parameter name is in the parameter list in the parentheses. Same thing with total tickets. Then just to finish out the class, I have a way to add tickets if I want to. I can get the student's name, typical getter and mutator methods. I can get the total number of tickets and so on. We're going to come back and look at this get amount here shortly and talk about these two methods right here. Now for bids, which is for the silent auction, again, same thing you're used to pretty much. I'm going to have an item name, a bidder name, a bid amount. I probably really don't need the item name because there's only one item, but I went ahead and put it in there. I'm going to pass all that in via parameter into the constructor, and here I've got my accessors and mutators and so on. And same thing with classroom. Instance variables, constructor. Here I decided to remind you that You don't have to use the this operator. You can use separate names for the parameter in and the instance variable, and you don't have to use this dot when you do that. Here I'm again doing accessor and mutator methods for this class. The only tricky thing about this is, in addition to those 3 class files that you're used to, and we're going to later implement this measurable interface, you have to have the idea of grouping. You have to have a way to say, let me take all of the students, all of the different teachers and classrooms, and compare them and see who has the highest participation. Let me take all of the bids and compare all of them as a group and see which one is highest. Let me take all of the players and compare them as a group to see who has the highest ticket number. So this one's a little tricky because you do have to have this extra class called group. So I've created it here, and I will give you the code for this. And what I'm doing here is just giving myself a way to use the interface and these classes to put things into groups so I can do the comparison. And then of course I would have my main. So let's look at main before we start talking more about the interface. So notice I'm going to set up a group for players, a separate group for, I called it leaders, that's basically teachers, and a separate group for bidders. And I'm creating those objects just as I normally would. And now notice here, I'm going to take the group object player data, and I have an add method in here that basically lets me pass in any type of object that is in this project, whether it be a teacher, whether it be a player, or rather a classroom or a player or a bid. I can pass any type of object into this add method of this group class. And when I do that, whatever numeric amount that I am tracking, whether it be bid amount, total number of tickets, or student participation, whichever one I'm tracking, I'm going to keep it accumulated in this variable sum. So here I put these at the bottom. I could have put them at the top. Here are my instance variables for group. Sum is going to track bids or players or participation depending on the object type. This relates to the interface, which we're going to talk about shortly. Keeping track of a total number of items for each group. I really don't need it, but I'm going to track it. Well, I do need it. I'll talk about that in a minute. And then the name. So I want to know who the highest bidder is. I want to know the name of the teacher with the most participation and the name of the student with the most tickets. So I have to have a name variable in order to do that. So we're going to come back here and we see that we can add player objects. Notice I'm invoking the constructor of the player here, and I'm passing it as a parameter in the add method to this player data group object. I'm doing the same thing with the teachers, but I'm using classroom objects. And then I'm doing the same thing with bids, and I'm using bid objects here. And you notice the syntax. That's the last half of what I would normally use to create an object, and I can pass that as a parameter to the add method. That's perfectly legal. Now if I wanted to, I could do this a little differently. I could also do what we're used to doing by creating an object, and then I could pass that to the method as well. So 2 different ways to do it. This way I can come back if I want to and modify via my accessor or setter methods. I can modify values for player X. When I do it this other way though, I really can't change anything about Jane or Jack or Wilma or Tom once I add them to the group. I don't have a handle or a name to go back and say, oh, I need to give Jane 30 tickets. I'm kind of out of luck on that. So if you feel the need that you're going to have to go back and modify something in that player, change an amount for instance, you might want to do it the other way where you give it a name, so then you can do x dot set tickets and so on. So 2 different ways to do that. So that's really not that difficult. Hopefully that makes sense. Now here's the thing. The interface allows code reuse, and an interface has a very specific format. Notice that it's not public class anymore, it's public interface. And this is the name of the interface. I'm just calling it measurable because that is a generic term, and that's kind of what they used in the book, so that's what I used. Notice that all that is in here, this is a skeleton. There's no implementation, meaning there's no code for these methods. Notice I also do not put the word public in front of double or string. It is assumed that all methods in an interface are public. They have to be because this is shared among the other classes. So by default they're public, so you don't type the word. And notice also it's the variable return type. So double string, or if it doesn't return anything, it would be the word void here. And then it's the method name and any parameters it might take. In this case I don't have any. And notice no braces, no more code, just a semicolon right after it. What this is it's a skeleton, or it is a contract. And what this means is any class that implements the measurable interface agrees that it will have these two methods. It will have a getAmount method that returns a double. It will have a getName method that returns a string. So it's a contract between the classes that implement it and this interface, saying that they all agree that they will all have these particular methods. Each class will do its own implementation of getAmount and getName, and we'll see that shortly. So now this ties back to group. So if I'm going to be tracking the highest amount and the name of the person associated with that highest amount, whether it's teacher, player, or bidder, I'm going to need two methods, getAmount and getName, in order to do that. So I'm going to come into my group here, this group class, and I'm going to pass to the add method. I'm not going to put player or bidder or bids or classroom here because I want this thing generic enough that I can use any object type with it. So notice that I'm passing to it a measurable object, an object of the measurable type. That gives me the flexibility to pass it any object that uses the getAmount method, which is specified in that interface. And that is why down here as my instance variable, I call it maximum. It's just another variable, except its type is the interface, and that is perfectly legal. So I'm creating a variable that has a type of measurable, which is the interface type. And that's going to make this generic enough that any of these classes that implements the measurable interface, I will be able to pass that object here to the group. I'll be able to keep a running total. This is just a running total of all the bids or participation or tickets. And I'm really not using that, so I probably could get rid of it, but I'm just showing you how I could keep a running total by saying x.getAmount, because each one of these is going to have a getAmount method with code in it that this group class is going to call. And then here's the little trick that I do need to use the counter for. If this is the very first item of a particular type being added, the first player or the first bid or the first classroom, my count is going to be equal to 0. And I'm going to say, okay, I have to assume that that first one passed in is the highest bid or the highest number of tickets or the classroom with the most participation. I've got to start somewhere. So I'm going to make the first one the highest, and then each subsequent time I'm going to keep comparing the new one that I passed in. I'm going to take its amount, compare it to the last one that I had, and if it is higher, I will swap them. If not, I will keep the original one that I had in there.